Assalamualaikum and good morning everyone. My name is Muhammad ZULHAZIQ bin NORAMIN. My matrix number is 2023239866 and today I'm going to share my little knowledge about queue and stack. But before we move to the coding, let's dive into these two first on what it's actually about. Starting with queue, which could be known alternatively as a waiting line, where you could say that it's similar to a checkout line in a supermarket where the first person in line is serviced first and other customers enter the line only at the end and wait to be serviced. Therefore, it is referred to as FIFO data structure, which is known as first in, first out. In the data structure, queue nodes are removed only from front of the queue and inserted only at the back of the queue. This leads to insert and remove operation, which is known as NQ and DQ. So as you guys can see in the visual representation, when we NQA, it will be inserted from the back. But what happens if we're going to add a few more strings on the linked list? As you guys can see in the visual representation, it will goes every time you add new strings, it will goes behind string A since we inserted from the back, so that if we are going to DQ, it will remove A first and followed by the rest. So as you guys can see, after we remove A, if you're going to DQ again, it will remove B and C until there is no longer a string inside. Now, let's move on to stack. As for stack, it is known to be referred as last in first out data structure, where the only element that can be removed, accessed or modified is the element that is recently inserted. The primary methods used to manipulate a stack are push and pop. Therefore, let's take a look at the visual representation. Here, you can see that string A is already pushed, and if you're going to add few more strings, it's going to push the string A further down. There you go. As you can see, I'm going to push string B inside A, and the string A will go down while string B will be on top of it. And if I'm going to pop, the string on the top will pop first and followed by other strings below. So in this part of the program, I will be explaining the queue class, which inherits from the linked list class. As we know, a queue operates on the principle of FIFO, which stands for first in, first out. This means the first item added to the queue will be the first one to be removed, just like a line at the ticket counter. Let's break down on how we're going to achieve that in the code. First, we will define a public constructor that simply calls the parent constructor from linked list. And as for inserting data, we use the method called NQ, where we will insert the object at the back of the queue. This will ensure that newer elements are always added behind existing ones. And for removing data, we use DQ, which removes the object from the front of the queue. This is what gives us the FIFO behavior, where the first element is always the first one out. So in order to pick at values without removing them, we have two getter methods, which is known as getFront and getEnd. GetFront will returns the element at the front of the queue, while getEnd will get the last element by removing it from the back and reinserting it, just to view it without disrupting the queue. And the last two method we have is isEmpty, where it is to check if the queue is empty, and the last one is print method, which uses the inherited print method from the linked list class to display the queue contents. Now, let's move on to the stack class, which also extends the linked list class, but unlike a queue, a stack follows the LIFO principle, which stands for last in, first out. This means the last item we insert will be the first one to be removed. Just like stacking books, the last book placed on top is the first one we take off. Let's go through the structure and methods. Just like the queue, we start with a simple constructor, which is public stack, which calls the parent constructor to initialize the linked list. For inserting elements, we use the push method, which will add the object to the top of the stack, which in our case is done by inserting it at the front of the linked list. For removing elements, we use the pop method, which removes the object from the top, again from the front of the list, matching the LIFO behavior. For viewing elements without removing them, the getter methods we have is pick method, which simply returns the element at the top without modifying the stack, and the other helpful methods, which includes isEmpty and print, where you can check if the stack is currently empty, and the print is for which prints the stack's contents using the inherited method from linked list. Now let's take a look at the main menu class. This is the provided and user inside to the program. Before we talk about the main task, let's take a look at the task class first, where we have declared all the attributes and stuff. So let's move back. And here's our main interface. We have user can add tasks, remove tasks, display the task or which they added, and they can even calculate the estimated hours from stack, and they can even copy data between stack or queue. And of course they can edit the program as well. So let's talk about the first thing, which is adding tasks to stack or queue. So when the user select this option, they are prompted to input all the details for a new task, including the task ID, title, description, priority level, estimated hours, due date, and whether the task is completed. Once entered, this task is added to the stack using the push method. The user push the first one because the stack calls the last in first out position, which means this new task will be at the top of the stack, meaning it is considered the most urgent or most recently added task that should be added first. But what happens if the user chooses the second task where we will add task to queue? It's actually similar to adding a task to the stack. The user will provide all the task details, but however, this time the task is added to the queue using the enqueue method. If the queue operates on before multiple, which stands for first in first out, tasks will be processed in the order they were added. This option is ideal for tasks that should be handled in the regular chronological sequence rather than urgency based. So let's talk about the next two cases, which is removing tasks from stack or queue, which is the number 3 and 4. And if the user wants to remove tasks from stack, selecting this option will remove the topmost task from the stack using the pop method. This means the most recently added or urgent task is removed and displayed to the user, indicating that it has been completed or discarded. If the stack is empty, the program informs the user that there are no tasks to remove. And if let's say if the user wants to remove tasks from queue, this option will remove the task at the front of the queue using the dequeue method instead. The task that has been waiting the longest in the queue will be removed first and displayed. If the queue is empty, the user is notified accordingly, where this operation models typical queue behavior where the first task to arrive is the first one to be processed or complete. And the next two cases is display stack and display queue. And if the user wants to display stack, then the program will traverse the stack from top to bottom, printing out all the tasks currently stored. And as for displaying queue, this option will print all tasks currently in the queue, showing the user the list of tasks in the order they were added. And for the case 7, which is known as finding value of sum, max, mean, and average of estimated hours from stack, where the feature will calculate 4 key metrics based on the estimated hours, which is the total sum, the average time, the minimum, and the maximum. Actually, this statistic will give the user valuable insight into their workload and help with planning and prioritization. And the last choice is to copy data between stack and queue. And before we go through all this, in this case we have provided 4 moves, which is queue to stack and stack to queue, and the other two is stack to stack and queue to queue. For the first two, it is for urgent task prioritization, and the last two is for like if you want to backup the data. And let's go on to one by one. So first of all, this important option enables user to copy tasks from one data structure to another. For example, copying all tasks from the queue to the stack or vice versa, or duplicating tasks within the same structure. This copying is useful for task prioritization. For instance, moving tasks from queue to stack to mark them as urgent without removing them from queue, or backing up tasks by duplicating them. It will keep the original data intact while providing flexibility in managing and organizing tasks according to changing priorities. So as you guys can see here, I have already added 3 tasks, where 2 tasks goes to stack and 1 goes to queue, which is up here. I've already added. And as you guys can see, we have drink and eat in stack and play games in queue. But first of all, let's try to calculate first the value of estimated hours from stack. As you guys can see, we have all the values calculated already, sum, average, mean and max. And what will I do if I want to transfer the data, copy the data from stack to queue, or the opposite? Okay, let's try out queue to stack first. So basically I'm gonna copy the data from queue to stack, and let's see what happens. So it says that copy task from queue to stack. So what happens if we display the stack? Let's take a look at the previous stack first. We have drink and eat, right? So supposedly if I copy the data from queue to stack, the latest data of queue will go to on top of the data stack just now. Let's take a look. Okay, there you go. As you can see, the data in queue just now is on top of the data previously in stack. And what if we did the opposite, where I wanted to move data from stack to queue instead? But first of all, let's remove let's try to remove task from stack, which is number 3, and it will display what data that has been removed, and it will say remove. Okay, now let's try to move the data from stack to queue. It will say that copied task from stack to queue, and when we display the queue, you can see that instead the drink and eat will be below the play games, because in queue we applied a FIFO structure where the first in will first out. And let's try to remove the task from queue. It will remove this one first, because like I said, the first task that goes in will be removed first. As you can see, this task will be removed first, and if we try to remove everything, remove drink, we remove eat, and if we try to remove it again, it will say that queue is empty. And same goes to stack actually. If we remove everything, it will say that stack is empty as well, and you can exit the program once everything is finished. Then that's all the program has. And that's all from me. I hope you guys learn new things, and that's all. Have a good day everyone. Thank you.